speak, I just want to say one word. When I speak, I like to have people think about it, what we're going to say in this manner. We're people that have something to say up here, but the key thing in this evening's program is your reflection on what your wisdom is telling you. So if you use us as a bit of a lever to get at your own wisdom, that would be really what we're looking for in this kind of an event. Now, I have a little bit of a problem having the idea of looking after our world from the point of view of the carbon account in opposition to looking after our world from the point of view of the economy or from the point of view of business, because I'm deeply involved in both. And I just want to say a few words about how that is. But it's very clear that the profit motive has created our modern world, and it's not going away anytime soon. And it's also very clear that the 400 parts per million that Annette was referring to is also not going away anytime soon. And that's an issue. But nature and human life are both organized in what we might call systems. Systems of balancing loops and reinforcing loops, where feedback comes back and either balances the system or reinforces the direction of the system. And those feedback loops are in place and exactly to keep systems in existence. So one of the reasons why things are so hard to change in this world is exactly those feedback loops. They're there for a purpose. That's the way the world works, is in feedback loops, and those feedback loops protect systems' existence. So when it's sometimes difficult for us to make change, it's because of those feedback loops. And so we think that, or I think that it's sometimes better to look at what is rather than to look at what should be when we're in these kinds of conversations around carbon. I want to talk for a few minutes about making investments for the sake of profit. And it's clear that the world needs a new energy regime. It's also clear that it will take years to install a new energy regime for the world. In the meantime, technologies that reduce the impact of the current energy regime will be in great demand and great demand creates profit opportunity. So now my company, Northwater Capital, is not in the first instance a venture capital firm, although we're doing venture capital deals. It's not a clean tech firm. We focus on intellectual property. So we're making investments on companies that have promising and unique intellectual property, and that intellectual property that we think will be significant. We then try to show these little companies how to connect to the market, because connecting to the market is what's going to continue to keep those little companies in existence. So we're not a green fund, but we're out to make money for our investors. But here are some of the investments that we have made to make money. Now, how many of you have one of these, a smartphone in your pocket? Now, if you've ever noticed on one of these smartphones, if you send 4 or 5 photographs to your spouse or to your friend at the same time, one after the other, your phone gets quite warm. In fact, this one is just warm, just being here in my pocket, bringing an email. Your phone gets quite warm in that because there are, in this little phone, there may be 20 different energy conversions. So you've stored energy in the battery in this phone, and then it has to be converted so that the voltage for the screen is different. There may be 5 antennae in this. Each one will have a different voltage. So you've got to convert the energy in this. And so one of the companies that we've invested in is a company that has created a new way to convert energy in one of these little phones. And it turns out that the energy conversions in these phones are about 88% efficient in this phone right here in my pocket. Our little company has figured out a way to create those conversions with a 96% efficiency. So that's half the energy that's being used in this little phone. Instead of being converted to heat, half of the conversion to heat is now going to be converted into useful purposes. That's an example of one of the things that we're doing in the world of energy. That company is called Arctic Sand. You may get the idea of cold silicon is what they're talking about with their name, and they're in Boston. But so in the next generation of iPhone, you'd expect to find that your battery will last a lot longer. You'll use less energy in that phone. We have other companies in similar fields. We have a company developing photonic chips so that the copper wire that is in data centers are one of the largest users of energy in our society. They're linked together. The computers in a data center are linked together with copper wire. And of course, that's an immense amount of heat that gets generated, and then they use a lot more energy to cool down the room that those computers sit in. So if you can reduce the amount of energy being used in those computers, that's a step forward in the use of energy. So One Chip Photonics, which is an Ottawa company, is creating chips that allow them to use, instead of copper wire, use fiber optics. And fiber optics create a lot less heat, waste a lot less energy, and that's one more way in which to reduce the amount of heat that is being generated and wasted. We have another company that's called MTPV. It's a photovoltaic. You're all familiar with using photovoltaics to convert sunlight into electricity. Well, this just converts heat into electricity using the same photovoltaics. That's another way of reducing the amount of energy that we're using. Another is Red Wave in Chicago. Red Wave, that company is using antennae to collect heat. Now you think of antenna usually bringing in a radio wave or something, but any electromagnetic wave in theory could be collected by an antenna. And of course the wavelength is very short with heat, and so they have to have very tiny, you can put more than 1 million in a little square of foil this size, very tiny antenna, and then you have to figure out what the mechanics are for turning that back into electricity and putting it back on the grid. So that's yet another. We have another one in the idea of collecting waste heat, and that is Van Dyne Super Turbo. It collects the heat from an engine and turns it back into power that puts on the powertrain. So these technologies are addressing one particular problem in our society, in our energy budget, and that is that we waste most of the energy that we so-called use. Most of the energy we have goes not to actually propelling something forward or doing work. Most of the energy that we use ends up in heat, and most being You may have this number better than I, but it's something north of 60%, and I wouldn't be surprised if I'm quite a long ways below on that. It's very high is the amount of energy that we waste. Now, any energy conversion is going to create heat, so that's, the idea is not to not create any heat when you're converting energy. The idea is, can you recoup that energy that's being expelled as heat and reuse that energy in a different form as you go forward. So waste heat is one of the major themes in our portfolio, and you can see some of the things that we've done. I want to talk just about two other things that we've done in our portfolio that also address the carbon balance. One is a company out of Austin, Texas that's called Skyonic. Skyonic, you know that companies pay very large amounts of money for scrubbing the chimneys, the emissions from their chimneys. So a cement plant or a coal plant, or if you've ever been to Sudbury, you've seen the smelters, what they're putting into the atmosphere. And Skyonic takes the emissions from those kinds of plants and cleans up those emissions. Now just guess how much they charge for that service. The alternative would be to maybe put a $100 million scrubber on a chimney at a cement plant. Very, very large expense. Well, Skyonic will do it for free. And the reason is because there are chemicals in those emissions that they can turn around, take out of those emissions, and sell the chemicals. So one of the chemicals is sodium bicarbonate. It shows up in your refrigerator when you put a little box in to keep the smell down in your refrigerator. Sodium bicarbonate can be fixed by adding salts to the process, and I'm very aware that there are several chemical professors here, and my degree is in politics, so I get a little nervous when I'm talking this way. But they can add salt to the process and then and turn the carbon dioxide into sodium bicarbonate. Another output is HCl, and HCl, there's a big market for HCl, so hydrochloric acid. So Skyonic is willing to do the cleanup of these chimneys for free. So that's just one of our others, but there's one other that I want to talk about, and it's one of my favorite little companies. I know there's one of the investors in this company in the crowd, and that's a company called Liquid Piston. Liquid Piston has developed a new internal combustion engine. Now, internal combustion engines have been around for 125 years or something, and obviously there have been a lot of engineers work on internal combustion engines to make them better. This one, the engine in your car, I should say, is maybe, if it's a modern car, it's probably 20% efficient, i.e. 20% of the energy that's available in the gasoline gets used to propel you down the highway. Liquid Piston is a company that can get an engine from being 20% efficient to being 56% efficient. So more than doubling the efficiency. If we had cars with the liquid piston engine in it, we could have 100 miles per the gallon. Now, liquid piston is not going to solve the energy crisis, but there are technologies out there that are capable of helping us through this intervening period while we're moving out of the carbon era into some new era. There are technologies that are available for doing that. And we're investing in some of those, and I'll remind you again, we're not doing it for the sake of the environment, we're doing it to make a buck. So that's a little bit about how we're approaching this.